There we go. Not only does this magnetic blanket protect us, but it's also changed throughout time. They've taken core samples and looked backwards in time and found that this shift every 10 years or so, which is pretty minor, and they just do that to update maps because, of course, if you're somewhere like Greenland or even in Seattle, even in the western part of the U.S., there is an angle difference between going true north versus magnetic north. And so the maps have those adjustments, and there's just like a little outer ring on your compass, and you would shift that outer ring because you can't move the needle. The needle stays pointing to magnetic north. But then you just shift the compass based on whatever your local declination is off of true north, okay? What I'm talking about is something completely different. They've taken core samples from the Earth and noticed that the North and South Pole historically have actually completely reversed a handful of times.
That is so sick.
And it happens over a fairly short period of time. They believe that it's happening over 1 or 2 centuries, which is like a blink in geologic time, right? And there are some corollaries. We don't know if they're causal, but there are some other things that follow this switch in the Earth's magnetic field. One of them is that there are a number of mass extinctions following the shift when it completely flips its polar axis.
That's not good.
Well, yeah, if you're one of those animals, that is not good. If you're one of those species that goes extinct.
We one of those.
A long time ago.
Yeah. So if we lose a couple of species after the, or maybe thousands of species of animals after this shift, what might be the cause of that? And of course, we can't go back and experiment on it.
Radiation.
Ian.
Because some animals have, like, they're able to sense which way to move.
Yes. If they are like pigeons or some other migrating birds, if they lose their sense of direction, absolutely, it could definitely mess up their migration patterns, right?
Fly the wrong direction.
What else might happen due to this flip? Anybody have any other ideas?
Current switch.
The ocean currents
Yes.
are affected by the magnetic field of the Earth?
No.
No. But you're right, if the ocean currents did switch, that would seriously mess with our marine life, and there's a huge domino effect that would occur. Daniel.
Cosmic radiation.
Cosmic radiation, yes sir. So, this is what happens with cosmic radiation.
I say we let the cosmic radiation come in.
Well, if the cosmic radiation is buffered or deflected by the Earth's magnetic field, what would happen if I allowed all the cosmic radiation into this room right now? Yeah, vast majority, if not all of us, would die. Now maybe, stop talking all at the same time. Maybe one of you would survive. Let's say Jody survives.
Why would you?
She's in the front row, she gets to survive.
I'm in the front.
Hey, look at that mass of hair. It's got to have some, like, protective radiant effects. So, Jody survives along with one other male student somewhere in this building. Makes sense. They're sitting right next to each other. So, Alex and Jody survive and go on because there is no other options. Not that you wouldn't make a lovely couple, but go on to reproduce with each other. And they have very susceptible cells in their body. Now, they survive the radiation, but what are the most susceptible cells to radiation?
Eggs and sperm.
Yes, reproductive cells. So it is very likely that even though they survive the radiation, their potential offspring will not.
Poor Alex.
Very, they probably would never really even have the ability to reproduce because of the damage from the radiation. That's why we all wear the lead, lap belts when you get your teeth x-rayed, right?
We play around with this stuff.
So, we try not to. Marie Curie tried that. It didn't work out so well for her. But on the off chance that their offspring survived,
What?
because their reproductive cells adapt or really are messed up. If they survive, though, perhaps those adaptations would be wonderful.
Or they'd be like reactive.
How would they do
Yeah,
that?
it's unlikely that they would be. So statistically, the chances are not good for their offspring. However, what if, let's say, all of their offspring had 3 arms?
Star Wars is real.
That's the new
That's
normal.
literally
That's the new normal, exactly. And so then they repopulate the human race with 3-armed children. Yes.
So,
Think about all the things you could multitask,
but they
though.
wouldn't have 3 arms, right?
What?
They'd still only have their 2 arms.
Well, yeah, but
Oh, these-
eventually
yeah.
they die and then nobody would care.
Right. But we're not going to know that they were the original normal,
Yeah.
right? Ian.
It's Adam and Eve.
Wouldn't that be like?
It's the new Adam and Eve. Go ahead.
Adam and Steve.
How would that happen?
With the 3-arm thing, I just
No,
made that
no.
part up.
Because if Jody had a baby,
Yes.
how would the baby have to do with someone else?
I'm gonna make lots and lots of incest.
Right.
A lot of incest.
Jody has 3 babies.
In those early generations, there weren't as many options. All right. So you see what is likely to cause mass extinction if you allow too much radiation into the planet.
Rumsey, you're gonna cause
Now,
There's a bunch of white people.
here's the thing. Oh, yeah. I didn't think about that.
Wait,
We
what?
need some people of color. Just because,
Well, eventually it would all just.
yeah, eventually we're all going to.
They have
That's
kids,
the
they all look the same, so then that's the new white.
That's true.
That wouldn't make any difference.
Yeah. Following all these mass extinctions, though, there was also a mass bloom of new organisms,
Because they're
which could be explained from this whole mutation thing. A majority of mutations are bad, bad, bad for the individual, bad for the offspring, etc. But every once in a while, you get a good one. Yeah, if you say Star Wars one more time, I'm coming back there.
Star Trek.
Okay.
Or Star Wars is better than Star Trek.
Do we have any examples?
The new Star Trek does this.
Yeah, we do, but it's on sort of a microevolution scale. So,
Wait,
like Drosophila that have a 24-hour reproductive cycle, they're flies. They're little flies. It's hard for, that's what I mean. It's too hard to experiment with this. All right, so the last shifting of the poles, 50,000 years ago.
Well, you just said it was.
What?
It happens about every 100,000 years, but the last one was 50,000 years ago.
no, it takes 2.
Oh, it takes 2 centuries for the flip to occur. The last time the flip occurred was about 50,000 years ago.
Doesn't it happen every 200,000 years?
Every 100,000-ish years. So we're about halfway through a cycle. Not really what's critically important here. You ready?
So, yeah.
After that flip, lots of species became extinct. But there was a new species that hit the fossil record.
Dinosaurs.
No.
Homo sapiens.
Almost.
What you call me?
All right. We're going to take a very short break in celebration of
Mark being gone.
Mark being gone. No. In celebration of, it's actually a real legitimate holiday, and it is today. So everybody stand up.
I forgot.
Everybody, stand up. That's close, and there will be some choreography, but I know you can follow it. Okay? Here we go, I think. Hold on. Oh, you don't want to leave before this? All right. It'll only take 30 seconds. Stop it.
Chicken dance.
Clap 4 times now.
Oh yeah, apparently.
And extra credit for the best chicken dance. Now you'll need a partner.
Go, Dan. Okay, get up here, Ramza.
I got you, Ryan.
Partner time.
What do we do?
There we go. Oh, I have some nice star points, Emma.
Well, Nick, do I get extra?
I'm still in the judging phase. Oh, I don't know, Maddie, I'm loving that.
Yeah, this guy.
Oh yeah, definitely.
Bye, Daniel. Oops. Wow. Oh, be careful in the socks. And partners. Partners. Oh, Sienna doesn't have a partner. Oh, how cute! Look.
Your 3-arm babies are still
Clap, 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 clap. Oh, you guys are almost as good as third hour. Once I get next, you can go sit down. Alright, you guys get extra credit and style points. Nice job.
Is that original?
You get extra credit.
Key change.
I know.
I'm really dizzy right now.
Stand up and then
You get danger points too, sock points.
I feel like introducing danger.
Emma gets definite style points. She had some like cowgirl thing going on over here.
Matt did that first. Don't you think the interesting things are
Well done.
Yeah.
It really is dance like chicken neck.
like I'll get the target.
You got rid of it.
Wait, is this how I go from today?
No, that's
Of course you did.
crashed my car.
My first measure as president, it's like a chicken neck.
It ends with.
Matthew, I signed up for that. That's all right. Took the high road. Who else danced back there than I did? Oh, dance like a duck. And now, why do they call this the chicken dance when there's so much quacking? I don't know.
Because people are too scared to do it.
Oh, is that? There's words? I don't know words.
I don't want to be a chicken. I don't want to be a duck. So shake my butt.
Oh, that's so original. All right.
I get extra credit for last time.
That was pretty good. You would be a good cheerleader. We actually have clapping classes.
Let's be real. Go for it.
It's hard to. There's a couple different ways of clapping. You can like do air, like have an air pocket that you know. But then real cheerleaders like just smack their hands together really hard.
What about speedy clap?
Like, oh yeah, cheerleaders that don't take it serious. Like, you know, I mean.
Let's go fair. Let's go fair.
All right, that was loud. Okay. So, physics gangster symbol. Are you ready?
Ow!
You all right back there, Ryan?
Ian punched me. Did not.
No touching. I'm going to take away danger points from both of you.
I didn't have danger points. I was in danger. That was
Style points, yes. All right.
can never take away my style.
So, this is a bar magnet. No, I'm sorry, a horseshoe magnet. And that horseshoe magnet has a magnetic field going from north to the south. What I'm going to do is I'm going to place a current carrying wire, or it could be a positive charge, either one, behave the same way, in that magnetic field. And I don't know if you can tell from the picture, but they're perpendicular to one another. It's drawn like perspective, okay? So the magnetic field lines are to the window, and the current carrying wire is into the board. Now, what do you know from yesterday about current carrying wires in the right-hand rule? They have a magnetic field that surrounds them. If I have now two magnetic fields, so the magnetic field from the permanent horseshoe magnet plus the magnetic field from the wire, what do we know about two magnetic fields?
They attract.
they align themselves until they're happy, right? So kind of cool. So that means there must be some effect when you put the current carrying wire into the strong magnetic field, right? So here's the effect. And I swear to you, walk on any college campus and throw out the physics gangsta symbol, and you will get the nod. If you're in the physics department, anyways. You know what the nod is? Right. It's just from neutral, slightly above, and then back to neutral. I'm actually taking classes. All right, so you ready? So here's the physics gangster symbol. You just throw it out there. And then the nod. So the physics gangster symbol relates, and by the way, don't do it this way. This way doesn't make sense. It doesn't.
Wait, do it again.
Oh no, Ryan. You need to put that away.
I missed it.
And this is probably why it's good that Annie's not here today, because this might be a little bit disturbing. These three vectors, think about it, are in an XYZ plane, right? So you have your index finger, your middle finger, and your thumb. Don't do it that way. That's just wrong. So I want you to imagine that your arm is the wire. Got it? So there's the long wire. And the middle finger is the magnetic field. You will never forget this. That is the middle finger. Wire, magnetic field, and this is force. Got that, Ryan?
Do it again. I forgot it. I forgot it.
Got it? So if I have a wire in an existing magnetic field, then it produces a force of interaction. That's what your thumb represents. You got it? Force. So current in the wire, strong magnetic field, force.
Dang it.
All right.
I didn't get it.
So let's use the board. Let's use the board as an example. The magnetic field is pointing to the window. The current carrying wire is into the board. So I want you to throw up the physics gangsta symbol. And now turn it so that the current, the index finger, is pointing into the board. So just point into the board. Now that's the magnetic field's not pointing the right way, is it? What are we gonna do?
Kill it.
Use the magnetic field.
Just rotate it, go into kill shot mode.
It's a kill shot.
That's right. That worked. Oh, Bridget, that looks painful. Bridget's like, ah! So which way is your thumb pointing? Down. So what would happen to this current carrying wire is actually would be pushed downward. And you could harness that force and turn it into things.
Ooh, I like these.
So let's practice. Let's practice a few
Yeah,
of these.
let's go through the hand sign again.
Yeah, you forgot it already, didn't you? Okay. So let's say that we have it is important that you identify and remember these. I've had kids ask me like, hey, could I write like with a Sharpie marker on my fingers so I can remember it for the test? And the answer is no. And then I've had kids who've taken it one step further and said, hey, what if I got tattoos? I, B, and F on my 3 fingers. And my answer is, you're going to get the right-hand rule tattooed on your fingers. Go ahead. So that's a magnetic field. Got it? Now let's say that I have a current carrying wire going like this in the magnetic field. Your job is to figure out, using the physics gangsta symbol, what direction that wire will be pushed. So the current is traveling to the right. The magnetic field is coming out of the board. So throw up the gangsta symbol and rotate it around until it matches and figure out which way your thumb is pointing.
Hold the fingers away.
Way down.
Point. And now just put your middle finger and your thumb. Just kind of open them up. Yeah, and then make sure they're all 90 degrees.
Yo, Jasper, got that. That's because the electrical field goal.
Well, and if you have hitchhiker's thumb, do you know what hitchhiker's thumb is? Yeah, don't. Oh yeah, don't follow that around. The force does not curve around. It's straight to make your thumb straight. All right, which way is the force in this one?
Down.
Let's see. Okay. Out. Wait a minute. This way. Out. Down is correct. Down is correct.
Is it really funny to watch kids take this test?
I love watching kids take this test. It's a little bit, it's sort of a sick pleasure because kids will be laying on the desk and kids like climb up to like, gotta do this to make my hand work the right way. I'm like, okay. Here's something sad that happens sometimes. Sometimes, especially if you're right-handed and you're frantically like concentrating and working really hard, you're like, okay, and then which hand is this? I don't. So let's try another one. Yeah. Actually, lefties are usually better because they're writing with their left hand. Their right hand's free. Now this one's a little different. Actually that's going to be 2. I'll change it to a B. All right, magnetic field lines. Force the current is down. Which way is the force? Sorry, let me turn it.
Force is going in.
There we go.
God.
Current, magnetic field, force. Current, magnetic field, force.
So is this one?
Wait, where's the
What's
So,
which finger's force?
current, index finger is pointing down. Which way is your middle finger going to point?
This way.
To the window.
The window.
So which way is your thumb pointing?
To the wall.
That's right, to the back wall. That's correct. How would you draw that?
With an arrow, the X.
With a circle.
A circle with a
Circle.
dot. Circle with a dot.
Wait, no, it's going towards the wall.
The back wall.
To the wall.
Out through your forehead, Ryan.
If it's like that, it's going that way.
Stop! Look, Ryan, you gotta turn it so that your middle finger points to the window.
Yeah, but the B's going that way.
It is. That's my middle finger. That's B. I. Which way is? There you go. The pointer. There you go. There you go. You got it.
Shut up.
All right. I am scared. All right. We'll try one more. And then I got a few more minutes. Let's try this one. Okay. This one I'm going to go kind of quickly, so watch carefully. Need me to move things? All right. Let's say I have a magnetic field pointing which way? Into the board, correct. And I take a positive test charge and just fling it into the magnetic field. Positive test charge is current carrying wire. So into the board, current carrying wire, which way does your thumb push? Up. The thumb is the pushing part.
There we go.
So eventually that charge will go up, okay? So it's just like current. A positive charge is conventional current. So now the current, now it's going up. Now take, okay, B, up. Oh, now which way will it get pushed?
It's going to make a square.
It's gonna make a
It is going to make a square, you're right. So then it'll get pushed to the left.
Oh.
And then when it goes left,
It's a square, so.
which way does it get pushed?
Squares are for squares.
Down. Now, That's the only reason it's making a square is because we looked at it in 4 positions. What if I looked at it in 8 smaller segments? What shape will it take? An octagon, good. It'll be like stop sign. And for extra credit, what if I took 12 little pictures of it?
Oh my
Ouch!
God,
Dang!
so not fair.
A dodecagon is true.
I know what a decagon is.
Nope,
Does that
just
count?
that. We were like, nah, no. Someone told me that earlier.
All right. And what if what if all the pieces were so teeny that you couldn't even tell they were straight? What would it make?
It would make a
Circle.
You did not zip.
Extra credit point for the person who knows
Tangential force.
the name of the really big circular thing that we shoot charges through.
Oh, neutron collider.
Nah,
It's down
I'm
for
going
2 meters.
silver.
You're going to the Large Hadron Collider! Oh my gosh.
Where are you? What?
Yeah, well, you're gonna be
It's being charged if you don't use it.
My dad's not
Yeah.
going and he almost threw it. He threw an actual child.
Yeah, I mean, that would like, if I was going, I might have like a crazy teenage girl moment. My voice would get high and sweet. Yeah.
Just you did.
It almost did right there, I know. Like, oh my God! The Large Hadron Collider! Okay. Do you think there's any math that goes with this?
No.
No.
Well, you would be wrong. What?
No, you're wrong, Miss Nick.
Yeah, right. When you have a master's degree in physics, come talk to me. Now,
Whoa!
oh!
Challenge accepted.
Oh,
lawyer!
Actually, that would be kind of funny. Julian, come back in 10 years. Master's in
PhD.
physics. Mm-hmm. Yeah. What?
physics from Princeton.
I don't have a job,
What
the college.
You could be a high school teacher.
I'll take over your job.
That'd be awesome.
Legacy.
That's like- All right, and it's awkward now. So, but having these 2 reproduce and have 3 armed children was not awkward. Force, current carrying wire, magnetic field. The stronger these are, the bigger this is. Does that make sense? More current, more magnetic field. The other piece that we're missing is how much. So what's the length of the wire that's in the magnetic field?
I already wrote this in pen. I can't put that out.
Squeeze it in.
I mean,
Force.
it's all multiplication, right?
I know, it's just multiplication.
Put it in
Or you can
there.
put
True! So true!
live or build.
what property is that called?
F equals
Current
bill.
is in amps, force is in newtons,
F equals bill.
length is in meters, and magnetic field strength is in Teslas.
Sounds like something we should be excited about.
Okay, I am. Named after Tesla.
Yeah, and what is a Tesla comprised
Newtons, amps, and meters.
So,
Two reasons
over
this is
amp
what
meters.
tonight, 21A number 4, 21B number 3. 21A number 4, B number 3.
in our book?
4, 3.
In your workbooks.
Oh.
We haven't used those in a while.
I don't know how this